In order to understand the K-mean algorithm and um, clustering in unsupervised learning, first let's look at the principle of K-mean. Principle also means logic. So I write the coding here. This coding are just the logic and the principle of K-mean. You see, it's not very long. It means this algorithm is also not that complicated. So we said we use the same data set as I showed you here. This data set. So in the beginning, we randomly select a few amount of data points from this data set. And this amount, we call it K. It's also another K value. So in here, we set K equal to 4. It means we choose 4 um, data points, randomly choose K, 4 data points from our original data set. And we choose each of, and then we set each of these points, which the points we choose, we said that they are centroid. Centroid. The reason is we calculate the distance of all data points in the data set with each centroid, and for each data points, it will have then it has 4 distance. The 4 distance means the distance with each centroid, four distance, and we choose the nearest one, nearest centroid uh, as this data points category. I mean cluster. For example, for this data point, after I get the distance with other 4 centroid, and then I find this one is the nearest. So I think this data points can belong to this cluster. So after we can in this case we can do the same thing for all of the data points, and then we just clustering the whole data set into 4 different clusters. So the green one, this green color one means they all the cluster centroid with or to this point, green color point is this data point, and the purple one is this one centroid, and the yellow one is here, and the blue one is here. And this is the first step. We just randomly select a few data points as a centroid and try to cluster the whole data set into 4 different clusters. And in the second step, we can do we call it iteration. You see the green and the purple and this is blue and the yellow, 4 parts and 4 clusters. After we get this first step, the next step, we get the new centroid of each category and each cluster. So we just get the distance. We find the data point in each cluster, and this data point, the distance with each one in its cluster should and add them together. The sum is the shortest one, shortest sum distance. We think that point is the new centroid. We can do the same thing for each cluster, and we find the new centroid for each cluster. You see here, new centroid for corresponding cluster. And the next step, we recalculate the distance of each data point. Each data point with the new cluster, a new centroid, new centroid. So like this, we calculate this data points with other 4 new centroids and get the distance. And then we find the nearest centroid, and we think this data point should belong to that cluster. So you see here, after I do the second round of second round of clustering, you see the data points clusters get a little changed. So in here, in this chart, in the beginning, it belongs to blue. After the centroid move to here, now we think these points should belong to this data points should belong to this clustering. And again, continue. We can recalculate the distance, the centroid of new clusters. Yeah, centroid of new clusters, and moves the centroid and recalculates the distance of each data point with four different centroid, and do the new cluster again, and continue to do this. We call this iteration. We do this until the convergence. So you may ask when we get the convergence. It means when we get the convergence and when we stop the iteration. So it's finally when we find the move, we can set a number, the moving distance of the new centroid. I mean the last steps of centroid, and this step of centroid, we get the distance of the moving of centroid. If the centroid's moving distance is less than a number we set, for example, 0.01, if the distance moving of centroid is less than that, we can say that the whole iteration come to a converge, and then we can end the iteration, and finally we think that this clustering is our follow. The final cluster is our final. The final cluster is the goal we get. So in here, finally, we split the data into four different clusters, and it looks pretty good. But you may ask, why is not like here? You may think this clustering is better. It's more reasonable than this one. Actually, it's true. I also believe the above one is better. But in here, why the computer algorithm give us the cluster like this? It's just because we randomly select in the beginning, we randomly select the four data points as the beginning centroid, and then we start to do the iteration. And so that four points is randomly selected. So every time when we run the algorithm, when we do the training and run the algorithm, it's different because we randomly do that. So it also makes sense why it's different, just because it's different. We randomly select a different data point in the beginning, so the result is different. So, but you can run the code at different times, you will get the different answer. So it means for the clusterings, every time the answer may be different, but they all make sense because the algorithm can cluster into the amount of clusters you need. Now, let's go to another questions.